Hello everyone, my name is Balaji. I'm an alumni of RMKEC. In this video, I'm going to talk about some details of what the small car tries to perform that you may see on the other video. So basically a helper video. Okay, let's get into some details. The car that you see in the video is a scaled version of a real rally car, probably 1/10 or 1/16 scaled, I'm not very sure. The car has a Jetson TX2 computer with GPU, which is capable of hosting neural networks. It has sensing components like Honeywell LiDAR and a basic IMU. Along with this, the car also has 2D depth camera, which is an Intel RealSense camera facing front. The car tries to perform three actions here. The first is it performs detection of the obstacle, and it classifies what kind of obstacle it is, and based on the classification it performs a distinct maneuver. So for this scenario, we consider three obstacles that we believe will replicate a real world obstacle for a self-driving car. So that is something that we usually see on the roads, right? So the first is a traffic cone, human, and a stop sign. Another consideration we have here is that the car knows its journey, meaning that it knows the map of its track it is going to go through along with the features in its path. Now let's look into some more details of how this car performs an autonomous drive. As I mentioned before, the computer has a neural network hosted. The neural network I mean here is the publicly available well-known object detection algorithm called Darkflow YOLO v3. So this network is trained on again publicly available dataset called COCO from Microsoft, but filtered only for three classes of our interest. When the car is put in the track, we construct waypoints from the start to the goal points, and the car tries to move through these waypoints. We program such a way. During this time, the camera which is hosted in the car continuously captures the frames ahead of the scene at 30 fps and at a distance of about 10 meters, and continuously feeds this to the neural network. Whenever one of the obstacles that we train the neural network on appears in the scene, the neural network captures it and outputs the type of the obstacle along with the bounding box. So the bounding box is nothing but XY values of the obstacle in the image. With this information and along with the depth information, we perform some mathematical calculations and coordinate transformations to predict where exactly is the obstacle from the camera axis. And then we code in such a way to perform a unique maneuver. So we did this in a platform called Robot Operating System, usually known as ROS. As you can see, the car performs a roundabout when it sees a traffic cone, and when it sees a human, it avoids hitting the human by going around, and then when it sees a stop sign, it comes to a complete halt. So this is how we demonstrated a self-driving car. This was indeed a brief explanation, but I hope I covered all of the points that I wanted to. Another important thing I want to mention here is that I'm a complete beginner, and this is my very first step towards learning self-driving technologies. So this was a very naive implementation what we have shown from one of my course project at graduate studies. I hope you liked the video, and if you have any questions, please feel free to reach me. I will have my contact details shared by the professor. Thanks for watching. I wish everyone a very wonderful new year ahead. Thank you.